Welcome, everyone. My name is Emily Rodriguez, and I'm joined by my colleagues Amandeep Singh Mann and Will Dower from MITRE to share the tooling of DevSecOps with you today. We work on MITRE's Security Automation Framework team, or SAF, which utilizes InSpec as well as other resources from Progress and the security community to ease and automate security validation for US government sponsors and commercial partners. We want to dive into what that security validation lifecycle looks like and demo some of the tools, all open source, that we use along the way. The MITRE, SAF, and Progress Chef teams have been collaborating really since the beginning of the InSpec project. As you can see, our teams have been able to bring exciting capabilities to the InSpec community over the years, including foundational capabilities like InSpec inputs, profile dependencies, and the AWS resource pack. Most recently, we've been working on enhanced outcomes, parallel execution, and attestation features. These InSpec capabilities can enhance your security automation workflow along with the MITRE SAF's open source capabilities, many of which are being merged directly into the core of the InSpec project. Let's get started. To start, I want to think of an example outside of the software context. Let's think about what you do to follow, what rules you follow to stay safe on the road. The law in the US is that the person in the front seat of the car must be wearing a seat belt. Your car, however, luckily does not come by default secured with you buckled into the front seat. So when you get in the car, you have to configure your seatbelt by buckling it in and securing yourself from vulnerabilities if there were to be an accident. Since you have to make a choice to buckle your seatbelt and comply with the law, your car tries to validate if you did buckle and notify you with a warning light or beeping if you're not safe. The security automation framework uses a similar workflow to secure software. We help teams plan what guidance will help them keep their software secure, just like the laws of the road. We also provide libraries and tools for automatically hardening and validating software based on that guidance, normalize other security data, and visualize all the information to properly inform teams of risks and vulnerabilities.
So Emily has given us a good overview of the scope at which the SAF operates. The SAF takes a holistic view of DevSecOps support. We organize our tools and processes around the idea of 5 pillars of security automation, which we call planning, hardening, validation, normalization, and visualization. Now, to build out a good DevSecOps pipeline, you're going to need to start out with a plan, because before we can write a good compliance profile to test a component, we need to answer a fundamental question. What are we complying with? What are we testing the system against? So if we're going to make a plan to secure a system, the first thing we're going to need is the roadmap, the guidance on what counts as secure. Now, some of you might be thinking, oh, well, that's an easy one. I write my profile to meet this or that government standard or this industry baseline or so on. You might be familiar with CIS benchmarks from the Center for Internet Security or the US government STIGs. But as you all know too well, DevSecOps environments are constantly changing. You can leave work on a Friday, come back on Monday, and find 3 new tools you have never heard of that are now somehow an integral part of your pipeline. So what we often see on the SAF team is that many of our sponsors are working in spaces where the guidance hasn't been written yet, and we, as the security engineers, have to help them create it. So how do you create guidance? Well, we're going to need to start from the beginning. As a great scientist once said, if you wish to make an InSpec profile from scratch, you must first invent the security guidance document. Carl Sagan said that. I think I might be paraphrasing. Anyway, we create guidance by distilling down existing high-level requirements, best practices, and standards into specific instructions for specific systems. In the government space, those high-level requirements usually wind up being what the government calls a security requirements guide, or an SRG. These are the human-readable documents written by the Defense Information Systems Agency, or DISA, that define the basic rules of the road for an entire category of system to be considered secure. For example, the SRG for operating systems as a group might tell you that all system users need to have a password with a minimum length. Now, general guidance is great and all, but we're going to need much more detailed information on how to harden a specific system before it's useful to a developer. So we're going to tailor down our SRG into what the government calls a Security Technical Implementation Guide, or a STIG. STIGs are aligned back to SRGs and give a security operator detailed instructions on how to check if a system is secure and how to fix it if it isn't. For example, a STIG might say that to secure the Red Hat operating system in particular, you need to have a minimum length of 15 characters, and it will tell you exactly which config file to check to see if the system is actually enforcing that rule. The output of this tailoring process is what we call STIG-ready content, security guidance that needs peer review by DISA in order to become the officially published standard for securing this system. DISA is the ultimate arbiter of what becomes a STIG, but they have to rely on the vendor community to build out this guidance in the first place, since they're the experts. Now, you can start using your automated STIG-ready content to support your pipeline while you're waiting for peer review. So you might have an idea of where our inspect profile is going to come from now. So let's say you need to validate that an application in your DevSecOps environment is secure. You determine that at present, there's no STIG for it. You need to write one. You need to create it and present it to DISA for approval as the official STIG for that system. Now, normally this would be a very manual process. It would just be you, a few colleagues, and a big old Excel spreadsheet of all the controls in an SRG or some other piece of security guidance. But we on the SAF team determined that the overall process of developing a STIG needs more support. So that leads us to the first tool that we want to show to you today, which is Vulcan, our web application for STIG development. Vulcan lets you import an SRG or other piece of security guidance, go through it control by control, and tailor it right there in the browser to create STIG-ready content in a collaborative and structured environment. I'll hop over to our browser and show you the process we use to do this. But just as a quick note, we named it Vulcan after the Roman god of the forge, not after Mr. Spock. Apologies to the Trekkies in the audience. All right, let me hop over to my browser and hop over to Vulcan. All right, so if I want to build a STIG, the first thing I need to do is identify the guidance we want to base this STIG-ready content off of. I'm going to go to my SRG tab. Now, this could be a STIG, an SRG, and it usually is, but really you can base your guidance off of any documentation that's expressible in XCCDF format, which is a type of XML document that DISA provides. So let's say I'm securing a web application. So I'm looking for the most relevant existing piece of guidance for that. I happen to know there's already a STIG for application development as a whole, which would serve as a good basis for securing a given web app. So I've already downloaded that STIG from DISA's publicly available website and dropped it off in this Vulcan instance. So now I can go back to my project view, look at my little demo project. Projects are logical organizations of new pieces of security guidance, which we call components. I'm going to crack open a particular component that I hope one day will be our STIG for my web application. So when I open up my component view, I can see in my central pane here, every single control that was in the original application development STIG, all 286 of them. If I open them for editing, I can see all my controls in my original guidance document on my side here. I can click on them and I can tailor them down to be specific guidance for a specific system. The workflow I will follow with my team is to start reviewing each control in turn, determine its applicability to the particular system I'm trying to secure, and write in specific guidance on how to secure this system. For example, the generalized STIG says you must provide a capability to limit the number of logon sessions per user. Because I'm the SME in this system, I know that you do that by going to the session.conf file, we'll say, and setting max login sessions to 5. So I add that on to my generalized guidance. I can even write in the inspect control body at the same time that I create the human readable guidance, the human readable text of the STIG. We envision that you'll be able to create the automated guidance and the human readable content at the same time. If I say the control body, I have an inspect control generated for me that includes not only the code, but a bunch of the metadata that we wanted to attach to it. The metadata pulls in all of the human readable content so that it's included along with the code. We also get a number of metadata tags like the NIST control family alignment, a CCI number, and a severity for this particular item. So you don't just want to check a value in a file with an inspect profile in a DevSecOps environment. You want to be able to tell people why you're checking that file and what guidance you're implementing. So it's very important to bake in this content straight into your inspect test. All right, so let's say I'm done with my control here. I'm going to request a review on it so that I can collaborate with my team and make sure that I'm producing good content. Let's say I've now done this for all 286 of my controls. Then I can go back to my project view and I will export this component so that I can provide it to DISA for peer review. And I can, in the meantime, even download it as an inspect profile right off the bat and get started right away with using it. Now, if I'm going to go back to my slides. So that's Vulcan. And that's our big picture overview of how the SAF creates STIG-ready content.
So keeping in mind that big picture, to use some piece of software, you need to get a stamp of approval or authorization to operate by hardening your system to comply with the STIG or other relevant guidance and validate that it's configured securely. So this is like the act of buckling your seatbelt and your car checking whether you're buckled. So traditionally, this was a very manual process, but the MITRE SAF team, along with Progress Chef and other members of the community, have developed libraries and tools to automate the process. Here we look more specifically at the SAF CLI utility tool and the hardening and validation libraries. The SAF CLI is a command line utility tool that has several capabilities. Will showed you just a moment earlier how you can export an inspect profile with the Vulcan application when developing security guidance. The SAF CLI can do that too. The SAF CLI uses the generate command to create a stub of an inspect profile with all that metadata based on existing guidance documentation. This means that inspect developers can inherit all of that control metadata and profile structure and really only have to write the describe blocks for the control logic. Also, the SAF CLI includes attestations to fully articulate your security posture by showing the automated test results with any results requiring manual review. And I'll demo this capability for you in just a moment. Additionally, the SAF CLI can be used to convert third-party security formats, which you'll see from Amandeep in a minute, and it can be used to easily view a summary of results or validate against a threshold for use in an automated pipeline. The SAF website has a complete library of hardening scripts. So these are all open source from various contributors and include Ansible playbooks, chef recipes, Terraform, Puppet content for automatically configuring components across the software stack, from operating systems to applications and web servers and so on. The SAF is also one of the primary sources for open source standards-based inspect profiles available in the validation library that span the same component stack with contributions from multiple partners in the SAF family, like VMware, Google, Microsoft, Lockheed Martin, Booz Allen, and everyday contributors, shared across GitHub and consolidated here on the MITRE SAF page. But now that we've seen libraries and the SAF CLI, what would be an example of automating this workflow? So here's an example pipeline in GitHub, but you could implement this in GitLab or Jenkins or anything. And here we're using Test Kitchen to create 2 EC2 instances, run the hardening content you just saw to secure it, and then run the inspect profile to validate the results according to the STIG, in this case for the Red Hat 7 operating system. So in this workflow, we create a vanilla and a hardened box to be able to compare the results. Once you have the results, we use the SAF CLI as a utility tool to view a summary of the results and validate them against a threshold to identify if your pipeline passes or fails. However, we just talked about how we're adding in this attestation capability. So now that we have that, we could also add that feature to the pipeline, which we're going to demo for you in a moment. But this would combine applicable manual attestations to the automated test results to determine a more full and accurate look at the overall security posture. So now we're going to look at the demo for the SAF CLI. So I want to show you the actual example that we were looking at from our pipeline from the Red Hat 7 operating system. For reference, you can find all the information that we share with you on our website, saf.mitre.org. So if we go to the validate library and check out the Red Hat 7 operating system, we can look at the recently run actions from GitHub Actions. And I want to take a peek at this workflow. We can see that we ran the vanilla and the hardened workflow, and that we have our artifacts, which are inspect results from our workflow. If we take a peek at the hardened workflow, we have several steps that lay the foundation for the pipeline, and then we run our kitchen test command, which does the creation of the EC2 as well as organizes the hardening and runs the inspect profile to create the validation results. And then here we use our SAF CLI via a SAF action in GitHub to view the summary of the results. In this case, we can see that the overall compliance was 80%, and we can see the number of passed, failed, skipped, and so on of our different results. And this will give us different categories as well. When we validate against a threshold, we can use any of these categories to create a file that specifies what we're looking for. For example, maybe our threshold is a minimum compliance amount, or maybe it's a maximum amount of critical failures, or that sort of thing. So we can validate here against a threshold, and in this case, we've been successful, and that way our pipeline can pass. If we didn't pass our pipeline and didn't meet the threshold, it would fail the pipeline, and developers would know they need to make a change. So we can see here that we still have these 4 skipped controls. And I can also show you this, that we can do the same sort of thing using the SAF CLI. So in this case, I can give you the same results because I have already downloaded these artifacts for the hardened and vanilla results. And let's talk a little bit more about why you would have a skipped control. So we have not applicable controls, and then we have not reviewed. Not applicable would just be out of scope for the test event, but not reviewed could be why we have a skipped result here. And that could be for several reasons as well. Maybe you need to do human validation for that control, or there's a policy or procedural test or something of that sort. So I'm going to give you a little preview of Heimdall, our visualization app, so we can find out a little bit more about this particular skip control. So I've already loaded up the hardened results into our visualization app, and I can filter down to find the not reviewed controls and then learn more about why they're there. In this case, I can take a look at all of the data here and look at this particular control ID and find out that this one was actually just disabled because it takes a really long time to run in the pipeline. So we could decide to manually attest this so that we don't have to run it every single time in the pipeline, and it can save time. That's another valid reason. So if I take this control ID, I can create an attestation, a manual attestation, by using the SAF CLI. This is also something you could do via a YAML file or an Excel file, and then you can, or in the future, we're hoping to add this to the Heimdall GUI itself. So in this case, I'm going to add the control ID that I was referencing earlier, and then give it some wonderful explanation, which you would provide more detail on in your circumstance. And this can be good for a certain frequency. So I'll give it 1 day frequency, but you could give it up to a year or more. And then I'll say that I was able to pass this based on my manual review, and who checked it? I checked it. So now I've only checked one test. I don't want to do any of the other ones, but you could add any more that you have here. So I'm going to quit, and then I can actually take a little peek at this attestation file and see that it really just has all that data in this case in a JSON format. So now I'm going to use the SAF CLI to apply my attestation with my hardened results to create a full result set, results with attestation.json. And then after I've done that, you can see I have my results. And then I can show them again in Heimdall to compare to my previous results and see that now I have 167 passed and only 3 not reviewed. And here, if I look at the difference, I can tell that from the first one to the second one, now I'm passing this control, and here's all my content from my manual attestation. So hopefully that's given you a better view on some of the capabilities from the SAF CLI. And now I'll hand it over to Amandeep to discuss a little bit more about our SAF CLI and Heimdall capabilities.
Waivers and attestations are super cool since they let you automate some of the last manual steps in an otherwise fully automated compliance validation process. Thanks, Emily, for introducing them. We worked with Progress Chef to add waivers as native inspect functionality, and we've been very happy to have worked with them to add support for attestations, which will be coming in Inspect 6 very soon. However, if folks want to get ahead of the curve, you might want to look at the Heimdall data format, usually referred to as HDF, which already allows you to use attestations, enhanced outcomes, and many other advanced features that we have been working on with Progress to build into Inspect natively. So why HDF? Now, I'm sure you're all thinking, oh no, an entirely new format that looks so complicated. Haven't they seen that XKCD comic? But it's not new. In fact, if you look closely, you'll see many familiar names and attributes, because HDF is just the parent specification for the output coming from Inspect's JSON recorder, which many of you already know and love. You can find out more about the schema on the normalized page on the SAF site, or look at our scripts and TypeScript library called Inspect.js, which we use to programmatically interact with Inspect's outputs and HDF files in Heimdall in the SAF CLI. But why HDF? That loosening up of the rules lets us have a lot more flexibility with what we can do. In particular, we can now use HDF as the target for data exchange in order to standardize and normalize data coming from not just Inspect, but any other cybersecurity tool. Let me say that again. You can turn your results from SonarQube, from AWS's Security Hub, from Nessus, all into HDF. And that opens up a world of possibilities. Once all of your cybersecurity scan results and findings are turned into HDF, you don't need to look at 5 or more different dashboards. You can look at just one called Heimdall, which we've seen earlier, but we'll discuss in more depth later. This saves you a lot of time and effort since you don't need to go to every single dashboard and then try to parse out the important information. Instead, everything that you need to know is brought to the forefront, such as metadata relevant to the particular guidance you're looking at, like which NIST 853 controls apply. Not to say that we leave anything behind. We take special care that all data is brought over into HDF when it gets normalized. Now you've got a one-stop shop to get the big picture for your security posture. CWEs, CVEs, SBOM alerts for vulnerable dependencies, misconfiguration based off of vendor-specific guidance, and so on, as well as the ability to drill down and learn more as necessary, like what the test was looking for and how to fix the results to get a pass. But how do we normalize all these results? One solution is to use the converters built into our TypeScript library, HDF converters, which is also embedded within Heimdall and the SAF CLI. The basic premise for how this works is that given a result set from an input file or an API, we can apply a consistent set of operations, i.e. a mapping, to convert those results into HDF. Here we have some output from a tool called Burp Suite, which outputs its results in XML. So we have to translate it into JSON first. Afterwards, we get to the fun part of actually writing the mapper. Burp Suite has a relatively simple format, so this mapper is on the smaller side. The key thing to notice is this mapping object. The mapping object describes how an HDF file ought to be filled in with all of the Burp Suite information. The mapper recursively iterates over all the mapping object's attributes in order to figure out the paths and transformations required to get and reformat the information to best be displayed in Heimdall. We all already know what ought to go where in an inspect file, so it's pretty intuitive to find the analogous information in this third-party cybersecurity results set and slot it into the right places in the HDF file. Data about the run as a whole should be in the controls, and whether you passed or failed should be in the status. For example, that bottommost Burp Suite attribute is called issue background and seems to provide context for the issue at hand. That seems to line up real well with the description attribute for an HDF control. All that's left after you've written the mapper is to add a few lines in this fingerprinting file, just 2 for Burp Suite. So that way it's possible to automatically determine which type of file you're looking at. The fingerprinting is a nice quality of life feature for Heimdall and the SAF CLI, so you can just give it a file and it'll automatically convert as appropriate. The SAF CLI is our Swiss Army knife that's filled with all sorts of functionality. But one of our most used tools is the convert command that features all the integrations with HDF converters. These integrations are usually extremely simple. Read in a file, run the mapper, and write HDF back out. And as you can see here, now you've got access to that mapper we wrote, but from the command line. First, I just wanted to show you the original Burp Suite file, and you'll see that big block of text at the bottom. Keep an eye on that one. Next, we're going to be running, in fact, actually just the help command for the Burp Suite to HDF command. So that way, you know that you always have assistance whenever you require it. Now we're actually running that command, and we provide that input file, the XML file, as well as now we're also outputting it to HDF. After we format this so that way it looks a little bit pretty and actually readable, we can see that that same block of text is still there. And now we're going to be using it via fingerprinting, so that way it can automatically determine that it was actually a Burp Suite file and run the appropriate conversion. And after we format it again, we can see that that exact same block of text is at the exact same location, and we can understand that it was the exact same process both times. We were just able to determine that it was Burp Suite automatically. All in all, it seems like it's only a rung or two on the ladder away from being a step in your pipeline that you can run after you've gotten the results from the scans your other tools have done, but we'll come back to that later. There we go. We already provide all these integrations and are continuously working to add more ourselves and in partnership with the community. Hint, hint, nudge, nudge, that's you all. PRs are very welcome. But I want to emphasize that we are real about HDF being a data exchange format. It's not a one-way street. We're willing and ready to meet you wherever you're at. Maybe you like how XCCDF or Splunk look more, and that's fine. We do our best to transfer all the data that you've got in your HDF file and put it into these other formats instead. Now you don't need to wait for all of your tools to write native integrations. You can just convert them into HDF and do whatever you want afterwards. The SAF ain't a my way or the highway shop. We're a framework where you can pick, choose, adapt, or create the parts that you're interested in or are capable of handling right now on your security journey. However, in our totally unbiased opinion, we really do think that the winning move is to keep your data in HDF. For example, it lets you use some really cool features in Heimdall that Will is about to show you. But first, we have a big surprise. We're working in partnership with Oasis and a few friends of ours on getting a formal specification for the Heimdall data format put together so that way we can use it in even more contexts. Expect more news soon.
Thank you, Amdeep. All right, so finally, we'd like to talk about visualizing the data that we get out of our tests. For the last half hour or so, you've seen how we can start with a plan, translate it into automation code, and normalize the output to enable good analysis. But now we actually need to do that analysis. Collecting high fidelity security data is nice, but ultimately you're going to need human beings to be able to understand the data that you produce. And as it happens, humans prefer looking at graphical representations of data as opposed to, say, 3,000 lines of raw JSON. Now, as Amandeep mentioned previously, there are plenty of dashboards on the market right now that could be adapted to do this kind of thing for you. Splunk, AWS offerings, and even the StigViewer app if you like. But like Amandeep said, if those tools are already part of your process flow, the SAF can still support you, but we prefer to use Heimdall. The SAF team developed Heimdall specifically to serve as the visualization software at the end of a DevSecOps security pipeline. Heimdall is intended to be usable by both the deeply technical system engineer, who needs to know how to remediate their vulnerabilities, as well as the business owner of the whole product, who needs to understand the overall security posture of their application stack. I'll show you what I mean with the demo. So let's go take a look at Heimdall Lite, which is our demo site that provides the front-end app code for Heimdall without any of the back-end data storage. I encourage everybody listening to go take a look at heimdalllite.mitre.org and take a look around. The site is available for anybody to use, and we uploaded some sample data to it so that you can see for yourself how things look when they're visualized. All right, so I'm going to hop on over to my browser. All right, so I'm accessing Heimdall Lite. I'm going to go to our samples, and I'm going to load up an inspec results file representing an Nginx web server that's having some failing tests. So when I load these inspect test results, I see summary data up top that tells me at a glance, things like how many passes and fails that I have. We can also see our not applicable results and our not reviewed results. Not applicable tests are active requirements that are either in scope or out of scope, depending on a condition of the system, such as whether a particular package is installed. You can't secure your SSH package if it's not installed, for example. As you may recall from Emily's demo, not reviewed controls are controls that cannot be tested automatically and need to be addressed by an attestation. You might recognize these categories from the new enhanced outcomes that we'll be able to use in Inspect 6. So that's the summary data. As we scroll down, we can see more details, like a tree map of what NIST control families were covered by your testing data. If I go down even further, we can see a table view of details on the individual tests that we've run. So this information is good for an overview. This is what our business owner wants to see, but we can also take a deeper dive into the tests and examine why some of them failed. Let's say I'm a security engineer and I want to determine why my system has 3 failing tests. I can click on these donuts or on these buttons up top to filter my output. I could filter by severity as well if I wanted to, but these are all medium. Now, if I scroll down and click on one of these, I get an expanded view that shows not only what checks failed, but why. I can see here that this value should have been 10 or less, but it was set to be 100. If I click on the details tab, I can see all of my detailed STIG data for this control included as part of the output of the scan. Not only can I see what I failed, but I can see how to fix it all from the same report. Now, let's say I've gone back and hardened this system to fix the issues that I've identified here, and I've rerun my inspect scan to generate a new results file. I can load that file, our Nginx clean sample, in addition to the old one right alongside. And then I can use the comparison view that Emily showed you earlier to allow me to see the delta between the test results, both at a summary view and even in a detailed view. I can see that my failing test is now properly set. Now, furthermore, we can load tests, we can load as many tests as we like at a time. And since Heimdall can ingest multiple data formats from multiple security tools, that means you can load up a view of the security posture of your entire application stack. If I go to a different tab of Heimdall Lite, let's say that my Nginx server is running a web application that I want to scan with OAuth Zap. This application is running inside of AWS. It's running on a Red Hat 7 compute node, and I want to also scan the web server itself. I can do all of these things at the same time. All of them get normalized down to the same file format so that all of them can be ingested into Heimdall at the same time. Now I can see a holistic view of my entire application stack and its security posture in a single pane of glass. Once I'm done, I can even export my current view in Heimdall back into a bunch of other different file formats, just like how the SAF CLI allows you to convert HDF back into other report formats. I can take what I'm seeing and drop it off as an XCCDF file or a CSV or anything you like. This process right here is the core of what the SAF tools are intended to do. We extend inspec and related security tools to bake in all of the metadata that security engineer needs to see in their test results. This is why we want to be aligning all of our tests right back to security documentation. All right, so we've talked a good bit about the SAF's tools that line up with it well with our pillars of security automation, but I also want to talk briefly about some of the supporting tools we've got in the SAF. The first is called Inspect Delta, which we've been working on in partnership with our friends at Cerner, and which we've recently folded into the SAF CLI as yet another tool in the Swiss Army knife. Delta is intended to support the maintenance of inspect profiles over time. And by that, I mean, like we said, inspect profiles from us are usually based off of government guidance. It's a very time-consuming activity to maintain these profiles when the guidance they're based off of get updated to a new version or new release. And for something like Red Hat, that could happen once a quarter. So if you want to keep your inspect profile that corresponds to a particular STIG up to date, you're going to have to get very friendly with the STIG's changelog. This is a giant time sink. Nobody likes doing it. Delta provides a workflow to change that. It takes an inspect profile and a guidance document as inputs, tokenizes them both, and does a comparison to find out what metadata was updated. It can then automatically update the inspect profile to match the new release. Now all the inspect coder has to do is take a look at the controls that had changed metadata and see if those changes were material enough to warrant actually updating the logic of the inspect control. It's much less of a headache this way. I also want to point out that we have a pipeline-ready integration for our tools in GitHub and AWS. You actually saw the SAF CLI GitHub action a little bit earlier during Emily's presentation. We have similar support for AWS pipeline features. And lastly, I'd like to mention eMASSer. For anybody unfamiliar, EMAS is the Enterprise Mission Assurance Support Service, which is the tool that you need to use to store your security artifacts for the purposes of getting an authority to operate from DoD. It has an API feature, but not much support for it. So the staff developed eMASSer as a helpful CLI tool for interfacing with your friendly neighborhood EMAS instance to drop off data, run queries, do whatever you want to do. Now, as with the rest of our tools, eMASSer is containerized and very flexible. It's intended to easily hook into a pipeline deployment. Thank you for your time and attention. If you would like to talk to us about anything you saw here today, we would love to hear from you. Please email saf@groups.mitre.org. Thank you.